Next is to walk through an example of go back in, following the finite state machines. So then we go back and recap. Go back and sender's finite state machine and the receiver finite state machine, just so that you can follow. And real quick, the sender side of go back in is this. If we get a call from above, we check real quick whether next sequence number is within the sending window, which is base plus n. If it is, okay, then we generate packet and send it out. And then check whether we should be starting a timer. And the condition to start the timer is if this next seq number is indeed, okay, the base, and then increment the sequence number. All right, so check whether the next seq number is within the sending window. If so, generate the packet, send it out. Check whether we should start the timer. So next seq number, whether it equals the base, and then increment the next sequence number. If we do not pass the condition where the next seq number is within the sending window, then ask the application layer process to wait. All right. Now, back to the example. Let's assume the window size is 4, okay, and the sender's application layer process is sending data all the time. So sender here gets call from above all the time. So let's see. In the first call from above, all right, the base and the next seq number are both initialized to 0. Okay. Now the first call from above is going to trigger, checking whether the next seq number is within the sending window. Sending window starting from base and window size 4. Next seq is initialized to 0. Is 0 less than 0 plus 4? Yes. So we generate the packet, send it out. And next to what? Check whether we need to start the timer. And the condition to start the timer is only when the next seq number equals the base. Next seq number is 0, base is 0. Cool. Okay. Packet 0 is indeed the first of the first flight. So start the timer here. And next is just to increment the next seq number to what? 1. So next sequence number here at the beginning is 0. Now increment it to 1. So if we get a call from above again, next seq number, is it less than base, still 0, plus 4? Yes. So generate packet 1. 1 here is the next seq number, isn't it? Send it out. Check whether we should start the timer. Next seq num is 1. Base is 0, not matching. So the second packet in flight does not start timer. All right, just increment the next seq num. So here, the third call from above will start from next seq num equal to base 0 and 4. Is 2 less than 0 plus 4? Yes. So we generate yet another packet. Next seq num equal to, send it out. Do we start a timer? Next seq num equal to base 0, therefore not matching, not starting timer. Increment the sequence number to 3. Right? Is 3 less than 0 plus 4? Yes. Generate packet 3, send it out, not start the timer because next seq number is 3 and base is still 0. Right? And we increment the sequence number to 4. And now we get the fifth call from above. And that call from above will check, is 4 less than base 0 plus 4? It's no longer less, right? So what do? We go to the refuse data part of the if condition. So the application layer process is asked to wait, and sender will pause sending for now. And these packets will go out to the internet and hopefully reaching the receiver. While there's a timer that's ticking and ticking, and that is associated with the base, the packet 0. All right. And here's to quickly review the receiver of go back in. If we get a call from below, the data is not corrupted and carrying the expected sequence number, simply extract data, pass to the application layer, generate the ACK, send the ACK, and increment the expected sequence number. And otherwise, just resend the ACK that has been generated previously. Now, the receiver. Okay, receiver here will be receiving packet 0. Yeah, it's not corrupted and it's expected, right? So expecting sequence number 0, receiving sequence number 0. Therefore, we send ACK, expected number 0. Next, yeah, we get a call again from below. Packet 1, not corrupted, and it's in sequence. Therefore, we send ACK for the highest data number that has correctly arrived and arriving in order. So these are being sent back to the sender. But packet 2, oops, is lost somewhere on the internet. But packet 3 will arrive. It's not corrupted, but is it expected? We're actually expecting what? Sequence number 2. So we do not extract data. We actually trigger the default transition, if you recall, and just resend the ACK that is previously generated. So ACK 1 is being sent again. So right here. All right.